if we want to be able to convert from degrees to radians, we certainly would want to go the other way from radians to degrees. And 28 is just that. Negative pi over 4. Right, so we're going to multiply it by this ratio that's going to convert it from radians to degrees. So we want to do it in such a way that degrees is in the numerator, so that we wind up with degrees, and that radians is in the denominator. We just want a ratio that compares degrees to radians in a way that they're both equal. So it's the same ratio as before, only it's flipped over. It's 180 over pi instead of pi over 180. You can see that the radians measure is going to cancel out the radians. Okay, now at this junction, let me say that pi is not the unit. Pi is not the unit of radians. Radians is the unit of radians. Now pi is usually in radians. Sometimes you'll see a decimal, but a lot of times pi will be there. Okay, so we are going to cancel out pi, but that is not the unit. Okay, it's not in pi's, it's in radians. All right, so that little bit said, we're canceling out the radians. That's what's down here, and we're winding up with degrees. Right, so pi cancels with pi, radians cancels with radians, and what we're left with is degrees. Whatever number exists or persists is the number of degrees. Then 180 divided by 4, that's 45 degrees. Negative 45 degrees, it was negative. And number 30. 14 pi over 15. Right. We can see just by looking at it, well, 15, a 15th of a pi. We've got 14 of those 15ths. We're almost all the way around to pi, so we're going to be somewhere close to 180 degrees. Let's see how close. We're going to multiply it by 180 over pi. That's going to take us from radians, and when I point to pi, I mean that radians is implied, and we're going to degrees. So pi cancels with pi, about 15 with 180. I think 15 goes into 180. 12 times 180 divided by 15. Yeah, 12. So this is completely canceled out. This is 12, and 12 times 14 is 168 degrees. So pretty close to 180 degrees like we thought. Okay, so that's all the conversions we're doing. Let's move on to number 33, which utilizes the area and arc length formulas. Okay, so this is saying there's a sector out there. Its radius is 3 meters, and its degree, or its angle, is 5 pi over 12. 5 pi over 12. All right, so this is a piece of a circle. It's 5 pi over 12, so that's close to 90 degrees. Okay, so it's this piece of a pie right here. This is 5 pi over 12. And the radius of this thing is 3 meters. So they want to know what's the area, right? This area, and this arc length. The measure, if I were to lay a string across this arc, pick up the string, lay it flat, and measure it, how long would that be? Well, for the arc length, that's S equals R times theta. And in this case, S equals 3 meters times, remember to make sure your angle measure is in radians, which it is. So we're in luck. And let's see, these cancel. This is 4. And since this is a measure of a length, like in real life, it's okay to go ahead and use the calculator and use a decimal approximation. So, or if you don't want to, that's fine too. This is 20 pi. It's going to be something around 60, a little bit more than 60. Right? It's 20 times something like 3.14. 20 times pi is a 62.83. 62.83 meters. That's how long this arc is. The area is times 1/2 times r squared times theta, making sure it's in radians. 1/2 r, which is 3 squared, times theta, which is 5 pi over 12. Let's see. Nothing's going to cancel out very nicely. So we can just throw all this in there. We know this is 9, so 0.5 times 9 times 5 pi over 12. And that is 5.89 meters squared. Okay. Make sure that all makes sense. Yep, very good. All right, let's do another. Let's do another with a little twist. 36. So r is equal to 18. Theta is equal to 25 degrees. That means there's a piece of a circle out there. It's 25 degrees, so pretty narrow angle, 25 degrees. And its radius from the center of the circle to the outer edge is 18 meters. Okay, so I go and I want to say find the arc length. Arc length is equal to r times theta, so it's equal to r 18 times what? Times 25? Well, if we multiply by 25, we'd be multiplying by a number of degrees, and we don't want to multiply by degrees. That doesn't work. We could use degrees in the formula, but then we would need to include in our formula some way to convert the degrees to radians. Okay, so instead of all that, let's just convert the degrees to radians, use that in our formula. Okay, so 25 degrees times, canceling out the degrees, that means 180 degrees goes in the denominator, and pi goes up here. Let's see, 180 divided by 5. So that's 5 pi over 36 radians. So 18 times 5 pi over 36, 7.85 meters. That's how long this arc is. Now let's check out the area. Area is equal to 1/2 r squared times theta. That's 1/2 times 18 squared times theta, not in degrees but in radians. Radians 5 pi over 36. squared times 0.5 times 5 pi over 36. That's 70 point. Let's see, 70.69 meters squared. I'm hesitating for just a moment here. There was my mistake. In this previous problem, this was not a 4. This was a 4. So we're doing 3 times 5 pi over 4 times, well, that's it, 3 times, or no, just 5 pi over 4. That's all it is, not 3 times that. So 5 pi over 4. That's 3.93. That makes more sense to me. If that didn't make much sense to you, good. You are a good math student. Alright. There we are. There's a good looking problem right there. 1/2, 18 squared, 5 pi over 36. We've done well. Alright. Now let's go to number 39. So here in number 39, we're kind of going from stuff we just learned and tying it to stuff that we previously knew. Do we know the value of the cosine of pi over 3? Well, remember that this is just a way to measure angles, and it's equivalent to a certain number of degrees. How many degrees is this? Well, we should not have to, but we could take pi over 3, multiply it by 180 over pi, and figure it out. Or I could remember that drawing that I made earlier, that we made earlier, this one right here. Pi over 3 is the same as 60 degrees. So, do I know the cosine of 60 degrees? Well, since I asked you to learn that, then you should, or it should be easily accessible. It's one of those common ones. The cosine of 60 degrees, the cosine of pi over 3, is going to be 1/2. So it turns out we do know that. Let's try number 40. Do we know the sine of pi over 4? Well, pi over 4, we can look at that drawing again, and that's the same as 45. So I do know the sine of 45. Yeah, 45 is one of those common angles. Pi over 4 is a common angle as well in radians. Do I know the sine of it? I should, or it should be easily accessible. It's a square root of 2 over 2. Now, how about 45? The sine of 3 pi over 7. If I look at the drawing that I made, I don't see that, and also I don't see anything that's over 7, right? And if I convert, let's convert this to degrees. 3 pi over 7 times 180 over pi. That cancels those out. And let's just do that. 180 times 3 over 7. That's 77.14 degrees. I don't know what that is. I don't know anything about 77.14 degrees. So, seeing as I don't know that offhand, now, rather than kind of recalling it from memory or looking it up in my notes, but eventually committing it to memory, I'm going to find it with my calculator. The sine of 3 pi over 7. 3 pi over 7. Alright. Now here's what we need to make sure of. We need to make sure, because I could also find the sine of 77.14 degrees. I found that earlier. I could put that in there. How does the calculator know which one I'm putting in? How does it know if this is radians or degrees? And it's not going to take pi as a clue. And you need to tell it that you're either using radians or you're using degrees. The way you tell it is to change the mode. Let's go to the mode right there. And I am using radians and not degrees. So instead of degrees, I want to select radians. And now, go back out here. Now it knows I'm entering radians here. And it's going to say that the sine of that is 0.975. Okay. And let's try 46. Why not? It's next. 46 is the cosecant. This is a good example. 4 pi over 15. Okay. If you haven't caught on by now, the way that you can be sure that if you know this or not, if you should be able to give an exact answer, right? This is exact. This is exact. The square root of 3 over 2 would be exact. But this is not exact. Okay. So can I give an exact answer or can't I? And I can't because, long story short, I guess, the denominator is not 2, 3, 4, or 6. Right? I know about pi over 2 and multiples of pi over 2, pi over 3, pi over 6, pi over 4, but not pi over 15. I don't know anything about that. So let's just go for it in our calculator. The cosecant, what is that? It's 1 over the sine of whatever angle, so 4 pi over 15. Make sure you do not use sine to the negative 1. If you use sine to the negative 1, that will not be correct to do cosecant. Cosecant is 1 over the sine. And this is 1.35. Alright, so that'll do it for 13.2. Thanks for watching.